Hi guys, welcome to WissenWorld. This channel is for the people who are interested in learning new things in science and technology. To know more and to stay connected, please visit the links in the description below.
In this video, we are going to see how to read input, basically a digital input with ATmega32. So let's see what is a digital input available in market. It is a push button. It is a 2-pin push button which is commercially available in market. And in this, when we press this button, then the two leads get short. But in market, there is also the 4-pin push button which creates a confusion that which pin is shorted with which when the button is pressed. So as we zoom in and we can see that this is connected to this according to this plastic body. So internally it is connected, hence these are already shorted and these two are already shorted, and it seems to be like 2-pin push button. It is compatible with breadboard, so it is available in market to work with. Now let's see, we can get the input in two ways as in push button is. So let's zoom in. Now let me highlight that a push button as an input. Okay, so for push button as an input we have to do, the thing is we have only two ways: as a positive input when the button is pressed, and as a ground input or negative input when the button is pressed. So there are only two ways. Now we will see that in theory or using the circuit diagram, how can we use it as in a positive input. Let me clear the screen first, and as you can see here, the positive, then the push button is over here and it is not connected yet. So this is the 5 volt and ground and resistance. This resistance is very important in case of the push button. Why? Because when it gets short, so here is the 5 volt and at the end it's ground. So if the resistor is not available and we directly short it using push button, so a large amount of current, that will be Imax, will flow through it, and due to this large current value, our microcontroller can be damaged. So we have to use this resistance for the current limiting feature. Now see, when the button is not connected, that is it's on, then the ground is connected to output directly, and here we will get the logic 0. When we press this button, so let me write it over here, that this means it's pressed. So the 5 volt is connected first, and hence we can get the 5 volt logic over here, which is also known as 1 logic. Let me review it, and now we will see how that ground input can be read. So here the correction is done with ground, then push button, then resistor, then 5 volt. Okay, resistor is doing the same work. Now look at this, here is a 5 volt and there is a ground, and here is the resistance and output. So when the push button is not connected, we will get only 5 volt or logic 1. When the push button is get closed, that means when we just make it close, when this is closed, so the ground logic come here and hence it make a logic of 0. Now we will see, let me delete it. Now we will see that what is the circuit diagram we need to use that positive and negative input with the ATmega32. So first of all, we have to place ATmega32, we have to press P and search for ATmega32. Then this is our microcontroller, we have to select it and press OK and place it over here. Now let's suppose we are using this port C, PC0 for the input. So we have to search for push button, PUSH okay, push button games, and OK. And this is a 2-pin push button, so we have to place it over right here and rotate it like clockwise. Okay, we will rotate it clockwise, and then now we will see that this is for the positive input. For that we have to place a resistor first and connect it to push button. So let's check for a resistor and press OK and place it over here. Now rotate it also clockwise and place it nearer to push button. Now connecting it to push button, and we have to search for that power and ground. So ground will be here, and let's connect it, and then the power to the push button. So this is the circuit diagram we need actually in hardware also. And now you can change here the name and other thing if you want according to you. And then now the rest thing is that we have to get the output from the joining of the push button and resistance. So let me fix it for a pretty. Now this is our circuit part, and we also look for a LED. Why? Because the as we press the push button, then we can get the output from using LED. Hence, I am setting it at port B 0, OPB 0, and we can use the ground here also. Let me connect it. Okay. Now setting the parameters, check it for the last 1111 and set here the 16 megahertz, otherwise it won't work according to our delay. And this is for the hex. Now we will do for hex. First we will create the project and then choose the device. So click on the new project. Let's wait. Yeah. Now press this. Type here your name of project. I'm typing push button ATmega32 and check for the first executable project and browse it according to your choice where you can want to save. And then device selection, it is necessary to do with your controller. You can make a filter over here that so that you can find it according to you, but we are using the ATmega32, which is the first one, and then press OK. Now here is the code. We will delete this command first. Now we will define that first of all build it so that it will generate a blank program which will be provided over the here, and we will just select our hex according to our path as we have in the directory. So going into it and again in debug and choose the hex and press OK. So we have done our hex part. Now we are going to do our coding. Now we have to define that FCPU first, that is 16 megahertz, and then util delay.h for delay purposes. Now we are using DDR-B as an output, so we will do 0B 00000001. Okay, for this the first pin will be set as output and rest pin will 0 as input, and the whole C port will be 0. Now let's do the coding. Pin C is the command for reading that input, and pin C is for port C, and pin B is for port B, and rest according to it. And we are on ending it with 000001. That means we are ending it to 1 and checking for that if this condition is got to be 1. So when we get pin C as 1, so it will be ended with this, and if the result is 1, then do the port B according to this 0B000001. Else port B remains off. Okay, what will happen by this? If we press this push button, so it will generate pin C at pin C, 0, it will generate the one logic and it will be compared through the if condition, and let run it. So nothing is happening. Why? As you can see, the LED is not glowing. Something fault here in the if command, I think. Yeah, I have written a pin C 0 instead of we are writing pin C. Okay, so pin C and 0B, and which pin we want to check, make it 1, and checking it that it's high or low. So as it is high, we are just pushing it. Let's start running. As you can see, when I press this, LEDs goes on and then off. But this process is under simulation, so it is working fine. But in hardware, there is a debouncing problem, which I will have a look after a while. So now let's change this schematic according to the negative input one. So we have to just replace the R and resistance and push button. So I am just making the circuit according to it, and this will change our code a little bit. I will explain what the code will be changed in case of ground input and in case of positive input. So let me connect it over here. Now I have connected it right over here, and we have to just change this to 0. Okay, for input 1 we have to check 1, and for 0 we have to check 0. Now build and let's run it. As I am pressing it, it's on, and leaving it, it's off. So now we are going to see and do thing to remove the debouncing problem, as in the hardware part, which is a hardware fault and we can't change it. So we will introduce a while condition, and we have to play with this while condition so that we can find our code to be like what we have to do whenever our code is getting stuck or something else. Let's see. I am writing the same command, which is the if condition here, to the while, and let's put else also so that we can find the debugging easily. And let's build it and go to our simulation. Now run it. As you can see, it is working just fine as the previous one. Why? Because the while condition is same and if condition is same, so it is getting true always and always and always. Now let's check it is happening or not. Shifting this port B to over here, and let's build it. Okay, we found that error, that semicolon is not present. So build it and let's rerun it first. Now we are pushing the button and it's getting okay. So it is same, but in that case it is not a good thing that we are using this while in the equal to 0 mode. So let's change it to 1, and we will see that what it will change in our code and in the simulation. Now let's run it and press it, then leave it, then press it. Then you can see I have left it and it is getting set. So it is a software problem which has been done over here. So we have to make a conclusion that what should we do to debug this kind of thing in our code. To do this, we have to just change a little bit in our code. Look that carefully, that let's change it over here. Code be shifted downward again, and let's build it. What will happen, we will see that it is a problem of this port B or the while condition. So let's run it, and as I am getting it close and open, so here is a problem with this, that it is not functioning as we are doing for the press and play button. So let's change the code according to some rules so that we can do the best thing. So we have to put a negation here and let's build it. Now running the code, and when we press it, it's get on, then off, on, off, on, off, on, off, on, off, and it is not getting stuck at as in the previous cases. So let's stop this and write it over here that we make a conclusion that what we read here, that what we read in the if command, we have to just compare its negation in the while command. Okay, so always remember while working with the push button or input using the push buttons that we have to do this thing. As you can see, it is not getting stuck, and we will see that in later videos while working with LED, sorry, push button matrix or keypad matrix, that these problems come with multiple inputs. So let's stop it, and now changing it to, for making a counter, let's say was up counter and getting a mirror over here so that we can make a successful connection. So this A will be become this pin and this will be become B pin, connecting the C pin, D pin and E pin. Now in this case, LED segment case, the while conditions is too crucial. So we will see how to play with this while condition so that we will get our output exactly in a very good result. So we have to change this characters segment which we have discussed earlier in the previous videos, and we have to change here a position that will start from 0 and go to the last bit. Okay, now we are changing the port B to increment the position. Okay, whenever this condition will be true, we will increment that position and shift this value to I. Why? Because whenever this condition is not true, so the previous value of position will be holded in the else part. Now we will shift port B as segment 7. Okay, and it is an array, so we have to provide a position which is I. Now we have to change here that all the pins are output, so let it write it as in hex 0xFF. Now build it and let's simulate our code. Let's see what will happen. As you can see, okay, we are working with port A and we have defined in code port B, so it will make a confusion. So let's change it to port A, DDR A, and here the port A on input. So build it and run. Let's run it. It is starting from 0 already. Okay, that's good. Then I am pushing it and it goes off. Why? This is because I think we have just incremented this I, but we haven't make that condition that it will just overflow that, and we are ending this while here only. Whenever the while is getting false, then we will increment this I, and we are polling that if I is greater than 7, then make it to 0. Now let's build and run our code again. We will see that 0 is over here and say 1 is mirrored. It's 5. No, let's make it again. Okay, as we have done mirror to LED matrix, so we have to again mirror it, hence the all the orientation was changed. This is 0. Okay, then we push our button once and we got 1, 2, 3, 4, 5, and as I have pressed it, it is not incrementing the condition. That is a good thing. 6 and then 7. Now we will discuss this that the while command is very important while working with LED segment or others output while working with the push button input. Let's shift this port A command to somewhere here. Let's suppose what will happen if we do this, and we will just put it in the while condition, and let's remove this semicolon. Build it. Okay. Call object 1 is not a function. It's line 28 and column number 2. Let's see what is missing. I think, is this a problem? Okay, here is the problem. We have to provide a semicolon. I think, yes, this is line. Now, okay, expected this before this. I have missed that curly braces. Yes, over here. Now let's build it and see what will happen. Let's run it. Now the 0 have never came, and when I am pressing it is getting on, and I am leaving it is getting a random number. Why? Because we are under the while section and it is getting true many times in a loop, and we can't just see it from our naked eye. So we have to change this to as it was in the previous one. That was a good place of port A and the increment value. Let's build it and let's see what will the simulation have. It was the same 1 2 3 4 5 6 7 8. Okay, it's 0. Why? I think I have made a mistake over this pooling. Yes, 0 to okay 9, it's 10, so we have to go above 9 as these are all 10 values. Let's build it and run it. 0 1 then 2 3 4 5 6 7 8 9 0 1. As you can see, we have successfully made an up counter using the push button, and here the while condition is very important. I am just saying for the debouncing purposes, because when you go with the actual hardware it will affect your results. So this if and while combination is very good using the push button. So if you have any doubt, you can put it or write it on the comment section. Thank you.
If you like our work and want to learn more, please support us by giving us a like and do share the video. Don't forget to subscribe and press the bell icon to get a notification whenever a new video is uploaded.